Hello, everybody. So, oh, I'll wait till I get to it. Okay, looks like we're starting the last module here. So this week and next week, we'll wrap up the semester. And the lectures this week and next week will be a little bit on the short side. We'll probably go back to the time we were taking a break most of the semester. And then that leaves a nice long stretch of time blocked out on your schedule to work on final projects, pass through assignments, and get everything caught up. It's usually a hectic week, and I like to front load courses so that we have time for that at the end. For the most part, I have a big stack of odds and ends, random things to go over. There's two pieces of content for this week. One of them is collection streams, more efficient ways to process through large collections of data. We'll see the syntax for it, but again, it's one of those things. It's really for large collections of data, more efficient for large collections of data, which by that I mean much, much larger than we would ever see in the classroom. Yet small for standards of the world in 2022. There are some very, very large data sets in the world that certainly don't fit in a classroom. So there's that, and then multi-threading is a very useful thing to see. There are some criteria where instead of our program just being loaded in and running, we split it up into chunks that all run independently and then put those results back together. We'll talk about that at some point in this module. I just have a sort of but for the most part in class, we'll be talking about, well, both of those things, that's what's on the homework for this module. But both of those things are fairly short to talk about and not super complicated to code once you see the pattern they follow. Input streams also include parallel processing. Since Java does run on a virtual machine, I remember back we probably talked about it in day one or day two at the latest. That early solution they had for cross-platform write once, run anywhere was just to create a virtual machine. And then the virtual machine has all of the device-specific things, and then we can run the same code anywhere. But we're running on a virtual machine, so parallel processing isn't as open as it is in some other languages. There are just certain cases where we can extend that virtual machine to include multiple processors on the machine, on the physical machine they're on if they're there. One of those being collection streams. It's somewhere in there, but I pulled out the notes and just useful things I think will be useful odds and ends for you. Like this first one, sitting on top of the notes that I pulled out. I guess this is a good place to start with the odds and ends. It's definitely not on the requirements, but something very, very useful. As our software grows larger and larger and larger, and we automate more processes, the chance increases that it'll be a while before we see the bug. All the automatic processes run, and a bug might happen, and then automatic processes keep running, and we have to go back through what had already happened to find it. So something we might want to take a look at is logging, which off the bat you're probably thinking immediately write a text file, and that's basically what it is, but there's a more structured form of writing the text file. More structured things, it's built in so that we can just include an object to handle all of the logging, whether it's just informational or warnings, or set a level to them. That's one of the things we'll see is that logging isn't just writing to the text file. We need to set a level to it, which often gets color coded. Y'all know some of that, right? Like The highest level is going to come out with red, somewhere in the middle, yellow, and then we have greens and blacks for when everything works good. That sort of step up, I'm just writing a text file. It's all built in for us. Do I have anything special in the notes? No. It's in the java.util package. We'll type one up here in a second. Contains a lot of classes to keep what's going on. And there's two big ones that we'll need. A console handler or a file handler. For our example, we'll probably just look at the file handler, but a console handler is exactly the same, and the name doesn't really leave much ambiguity for which one goes where. But in general, with login, we probably want to send it to a file because our software grows larger and larger and larger. We're going to have more automated processes, which means it'll be a while before we know a bug happened. And then we have to dig back and figure out what the software was doing an hour ago when that bug showed up. So logs are incredibly useful for that. We'll look at a file handler in an example. The logger is the class, name of the class that handles it, that actually takes care of it. And there's also a log record, which is the instance that other things can access. So unlike a normal text, if we just manually did all this to a text file, we'd have to manually set up a bunch of stuff to parse through that text file if we needed to automate things. But the logger is already set up for that, so we can write it to a log, and other software can use that and access the level or how critical, important, whatever we logged was. I guess the two extremes, there is an informational, or maybe three, informational to warning to error. That's kind of the spectrum we cover with our levels. Let's just look at an example of it. I think everybody's already familiar with what a log is, right? Just keeping a record, detailed records of our program. I'll go ahead and create a new project for logging. Yeah, might as well create a new project for everything this evening. And I'll just call this logging. That sounds like a good name for it. Clean up all this stuff in the template that we don't really need. And most of what we need, most of the stuff for logging is in the util package. So we can import, excuse me, java.util.logging. I'll just import everything from that package. And the first thing we need, a log is just a record of our messages. So the first thing we need is, are we going to do the console or file handler? I'm going to do a file handler for the example, but the console handler is exactly the same. It just goes to a console instead of taking it to a file. So file handler, I'll call it FH. New file handler, y'all probably could have guessed that. And then we need some sort of name for it. My records.log or something. It's a text file, but usually logs are treated a little bit different. For one, they're going to be color coded. And not all of our text editors will show the color coding. If the text editor will show color coding, we'll have that color coding log and things like that. And then we press in true, and I'm suddenly drawing a blank on what the true stands for. And making my note. A pin, yes. So if we omit that second one, what is it like that? Oh. If we omit this, it will overwrite the log every time. So by default, it's false. And if you pass true in, that will handle appending. Some of y'all probably can take a pretty solid guess of what the error message is without looking. Do you have any thoughts? It's one we've seen before. We're working with a file, right? What could go wrong? What's the main thing that could go wrong if there's no file? Yeah, the file could be missing, could have been moved, could just be generally corrupted so that we can't add to it or open it back up. But I guess the main point is things can go wrong when we're working with files. So we need to worry about the IO exception. With a log, there's also a security exception. I'm just going to do a basic try catch and that's interesting. That's different than the default when you insert a try catch block. When we did that, when we clicked the light bulb before and default inserted a try catch block, it just automatically printed out the stack trace, I believe. But this time, since we already imported java.util.logging, that generic template version of the generic template version of the try catch block automatically logs it properly. That's one of the most useful things to do. Go ahead and do that import, just java.util.logging, and then stick the asterisk on there so it's the wildcard. Everything in the package we have about logging. And then your IDEs, most IDEs for Java should jump to that right there. Your template goes to a nice formal log. And here we can already see some of the stuff we're going to look at. So level is an enum of levels. We'll pull it up in the predictive text when we get there in a moment. But severe is the most extreme case. I guess I assume except an IO exception is the most extreme one. I want to try to throw an error real quick because I'm not sure where that writes to. I don't see a file name there. First thing I did was set up the file handler, but I can't help but notice that theirs doesn't have a file name. Probably don't need to do that on purpose though. I'm sure I'll make a mistake at some point. Y'all know how coding goes, right? Little typos happen, all that sort of stuff. If I don't accidentally make a mistake, we'll come back and make a mistake so it does kick out of that try catch block to see where that log goes. Because they most definitely did not put a file name there. They're also going to be using a slightly different format than I was going to use, but I didn't want to show that because that's a very, very useful thing we get in most IDEs just by importing that package. And in order for the template to switch to that, you do have to do the wildcard import. So everything in the package, it won't be enough if you only import one thing. But before we can I like to jump outside of the try catch block and actually create the logger out here. So our object is called logger. I'll just call it my log. That seems like a good name. And then we can't do a new instance of it. We have to do logger dot something. And some of our options are get an anonymous logger, or get a particular logger. I guess that's our two options. It can either be anonymous or we can give it a name. And you'll notice that the first, well, one of them has a resource bundle name. That's files and a whole bunch of other things where you do. It's just a string of how to organize this stuff. Oops. Logger dot. And the other one has a string for a name for the particular logger we're using. I usually use this one, and internally it's basically like a key. So we have two ways to access this logger. We either have that tag or sort of a key from a dictionary or a map, or we can use the reference value. That's how I usually set it up myself, but as always, there's more than one way to do things, right? Either way, as long as we create an instance of the logger object, but we cannot create a new logger object. It does have to be get anonymous or get the logger. I guess here they were using the resource bundle, so the one they pass null into is a resource bundle, so even the template just ignored that. Usually it's better to just go ahead and use your handler. And once we have a handler and a log, then on that my log object, we can add a handler and just pass in that reference we made. Which that will be enough to give us a black and white log. But it's not really a log, it's black and white, right? We need to know which ones are yellow and which ones are red so we can so we know whether to pay attention to them or not. Y'all are used to those colors especially, right? Probably don't even read stuff that pops up in yellow. It's like, oh, there's a yellow, no need to even look at it. But when the red things come up, then we know it's important. So we need something to format it, and those standard colors are going to be under a simple formatter. I'll just call it SF. And again, that's a new sim. That's just going to be a new one. Oh, not simple simple formatter. I typed an extra R in there for some reason. And that gives us the standard colors, the ones that you're used to from debugging your programs. The reds and the yellows, every once in a while a green. Mostly black means it's okay. And then on our file handler, we can, well, you can see the options there. I'll pause there. We can decide how it should be encoded. By default, it'll be Unicode. That being said, so far in this last, I can't remember explicitly saying those words. By default, everything in Java is encoded in Unicode. So anytime we have a character, it's 16 bits. Anytime we have a string, it's a collection of 16-bit characters, unless we specifically change that. And when we change it, we just look up the name of the particular one. There are other encoding schemes, but it's rare that anybody uses them. The first time I taught the Java class, it's the only time I've ever seen anybody use another encoding scheme. And that's because he wanted to do a project for the CNC machines where he worked, and it was a very specific German-made CNC machine. So in order to connect his Java program's output to it, he had to use this custom encoding. It's a CNC machine, so they don't need the full every symbol that humanity makes. They needed a few special characters saying which bit to use. Is it the wide flat bit, the wide pointed bit, an arrow pointed bit? Just a few small symbols for that, and then 3-dimensional coordinates and 3-dimensional angles. So that's the only time I've ever seen anybody change encoding, but it's built into a lot of places. by default, it's Unicode, but that's usually what we want anyway. An error manager, so that's something that would go more along the lines of those text blocks there, where we're gonna log stuff from our program. Or that example I started off with, if things are fully automated, it'll be a minute before a human knows about that message. So we'll need another automated process to keep things running until a human finds out about it. Jump to another program, error manager sounds fancy. Jump to another programmer that automatically sends the IT department an email that says something's broken, and then cancels the current application and starts the next and automated process, that sort of thing. We have to set those up ourselves and then explicitly say that it's an error manager sort of thing. Filters are like filters always are if you need to narrow things down. And a formatter and then set level is the priority for what goes to the file. If you want everything to have the same priority, everything's informational. A lot of CAD programs are like that. To keep track of it, what the graphical user interface the engineer is doing, they're dragging their mouse around, putting together the model of whatever it is. Right? Like it may be a really, really perfectly accurate bolt, so they can run simulations and see what happens when they apply thousands of pounds to that bolt, connecting things together before they make a physical copy and risk hurting somebody or something if it's not going to hold. Those sort of 3D modeling software, the graphical user interface, the buttons and all the clicks and stuff go to a text file and write out all the instructions as the engineer's going through them. And then a different part of the GUI reads that text file and then puts it on the picture. It works really good for undo stuff or to redo stuff. And recovery is always really neat. I always like deleting files and recovering from those text files because it's everything that happened along the way. So if you click the recovery option, it just goes to that text file and you get to watch a little animation of everything you did making the product. So something like that, you would just go ahead and set that everything is information. But generally, we're going to set the level message per message, not overall. What we want here is to set the formatter, and yeah, there's only one formatter available, so it's already predicted that. Simple formatter is the one we want. And that sets up our log, so now we just start doing stuff and track it along the way. What can we do? Just printing to the console. So then we can say my log dot. So there's a couple options. It would just say log. This is going to be the generic catch-all one, the second one. So what level is it? And then what is the message? So I'll do one that way. So log with level dot, and here's our level. So all levels, configuration level, fine, finer, finest, info, all severe, warning. Choose one of those levels. I would have made warnings before severe. They go in order there. Oh wait, no, that is alphabetical order, isn't it? Oh, that's alphabetical order. So warnings, informational, severe, and warning are the three you're probably going to use most often. And that's going to be your black, yellow, and red that you're used to from debugging. This seems like just informational. And then the message we want to send is printed some stuff to the console. So just logging what the program's doing. What else can we do? Let's make a list, maybe. A linked list of vendors, just for a generic example. List is a new linked list. Go ahead and import that, because in this case, it'll be fine to go ahead and do the specific one. I believe we've seen that asterisk before, right? I think all semester I've mostly been doing the keyboard shortcuts. Right. And that goes all the way to the exact class of game. The wildcard selector, we can back up one spot, it's basically the folder, and import everything from that folder, not just the class. We may not have looked at that much. But that one is needed in order for your put logging in the catch blocks automatically. Then we can log that. So my log. And another way to do this, instead of log, you can see there's a lot of things here. Config, that was one of our levels, right? If I scroll down, find and finer, those were also one of our levels. In finest, the skip eyes, realize, oh, info, that was one of our levels. It's actually the one I want here. So this is the way I normally do it. Instead of log, instead of the .log and then say what level it is, all of those levels are also a method name. And it just makes more sense in my mind doing it that way. So informational, what do we just do? Made a linked list. Then list.add 3. My log.info added 3 to the list. List.add 7. My log.info added 7 to the list. You all know how logging goes, right? We want to keep track of everything that happens. So it's mostly informational. Put an arbitrary warning in here. My log.warning. And you would get the same thing if you just said my log.log with level.warning and then the string. At least it just makes more sense in my mind to do it this way, then the information or warnings would go down here. I guess those would be severes, which is what they are. So testing the log warnings. My log.severe. Testing the log severes. There's really not much to it, and I think you all probably have, even if you've never read a log, you probably have some idea of what would go into a log, right? It's going to be unique every time, but that's the main thing. You can see that there. So when we run this, so notice we got a few things. So the black is what we printed out. What we actually said print out. And then everything else is red. I'm just expecting info to be black. Last time I used simple formatter, info was black. I'm not sure why the simple formatter doesn't seem to apply. Maybe that's a good reason to look at the books. But you can see all that log, just saying what's happening all the way through there. Did I make a typo in the formatter? No, good reason to check the logs. Simple formatter, Java. Or- oh, it's defined in the configuration of the system. So I guess the colors are just NetBeans only prints in red if it's not the direct output, it's only in red. What other options do we have on formatter? Formatter, descriptor. Simple formatter or XML formatter. So I guess we only have the two options. I thought there was a place to put colors in simple formatter from last time I did this lecture, but maybe I did something different. And I apparently didn't save the file from the last time I did the lecture. I have the file from when I was getting ready for the lecture, which is like very, very minimum. And I didn't bother to save the one from the thing. Oh, yeah, we have to do all this. That's right. I remember looking this up last time. Anybody ever seen the color coding used in a bash shell? So when you customize your bash shell, like open up Kali here. Once the machine boots up, and open up bash RC. So here's all the customization stuff for this. Why is that in black and white? So here's how we format the colors in a bash shell. Actually, I have a better example of that. Where's this one? This is one I did myself. VI/Etsy/ bash RC. Oh, that's not where it is. Like that. I have no idea why I just did that. List out what's in Etsy. Oh, we try that again. List out what's in Etsy folder. I have no idea why I was just trying to use backslash in a bash script. That was that's not even an excusable typo. A backslash is nowhere near a forward slash. Slash dot bash RC. Oh. Let's see if I can find the file now. I thought it was up there. Profile.p. Oh, there it is. I was looking for the wrong one altogether. Bash. I think it's in kick prompt. That's right. This is my bash shell that doesn't have a bash RC file for some reason. I've done that before. Configurations are always in bash RCs. Yeah, so here's the colors on the bash shell. So 033 followed by 32. Then we enter the username and the home directory. So if I leave VI here, so 33 is going to switch it to the color green, and username Then we go to the home directory, switch to a different color, and the colors are coded like that. So we have to put that stuff in. I remember doing it before. I thought it just happened, but as soon as I saw it here, I was like, oh yeah, I remember looking that up. It's you would probably find more useful reference if you search for color coding your bash prompt. There's going to be lots and lots and lots of stuff on that. It's going to be kind of minimum here. Other point, you can indent it and stuff, but the basic idea is there. And we said to use this file. It definitely printed to the console here. So let's look and see if it gave us a file. I think that's what it was, right? My records. Oh, that's going to open up there. So we get that back, but we get that log of everything that happened. So it's missing the output, like the actual output, but everything else is kept track of. So when things go wrong, we can see what's going on with the system. It's a useful thing, and it's really just a lot of echoes worked into your code, and they go to a specific place where a network administrator or the local IT guy or something is going to have access to that file to know where it is. So in general, you would probably put it to the installation path of the software, not or a specific file for logs, so the IT guy could find it. Otherwise, in general, nothing too fancy about that. Y'all can look at the list, see what's there, and keep track of information. Let's make an error here somewhere. What's a good error that will kick us out of this? I can do this. Well, true. If that needs to happen. Well, if is a new file, go into that same file, my records.log. And scanner S is a new scanner. Look into that file. And it's a linked list of strings. I'll call it lines, do linked list. And while true, lines dot add s dot next or next line. That work. Eventually, that's not going to be true anymore, right? There isn't into that file, so at that point, it won't be true, which is actually an error. It's a 1-bit way to exit a loop instead of multiple bits involved in a full selection. So if we know the exception is going to happen, we can work with it, and it usually involves less processing to deal with an exception than to do a big fancy formally correct way to do it. You will sometimes encounter code where people do that. If they need to optimize it, the fastest you can make a computer work, it only involves exceptions. And when you see a program that's written that way, it is an awful, awful mess if you're not the one that wrote it, because the program depends on the unhandled exception. So you have to look through a big list of try-catch blocks, like we have on the screen there, catch all those different exceptions. And there's gonna be one exception that the programmer knows is gonna happen, but is left off that list, so that we just bypass it whenever that exception comes. It's more efficient by the time it compiles to machine language and runs through a CPU, but it is an awful thing to look at in the text file. Even if you're the one that wrote the file, it's a mess. Just in case you ever encounter that, where you have a huge list of catch blocks and it doesn't make a lick of sense and you're not hardly doing anything, it might be using that sort of thing. So that should eventually log out of here. Let's make sure we in the IO section. As out in the security exception. There we go. No such element exception. What? Oh, I guess I have to actually is that the line that was on line 36? Oh, I guess I have to actually do that. Catch a no such element exception, which actually I'm kind of glad that happened, because that is a much better example of how I usually put together the try catch blocks. Whenever one happens, then I catch that exception instead of trying to think ahead and see what it is. I start putting the algorithm together and then look for which ones it is. And for this, I'll just copy this. Oh, I do need an X here. Print this and S out in the no such element. So, which probably needs imported. Yeah. Let's see what that log does. So where did that happen? Okay, so here's where it happened. Then our log threw it up to the console. Where it happened, the severity of it, and then what the actual exception was itself. Notice for the string, I just passed in that exception. We would probably, the stack trace from the default just exception by itself, when we try to print it, it's going to give us the stack trace, even though we have a method to print stack trace. So usually we would have some better string. So, but we knew it was going to go to the console. Let's see if that made a different log for us, bringing the files. I don't see another one. We're going here. Oh, we didn't get the we didn't get that severe one here. And I don't see a file here anywhere. We look at test, there's nothing in test. In source code, we didn't get a new log here. In the project, it's still just the normal build files. Nothing in private. And the build file just has our classes. So that one, those default ones do not get saved. But if that's something you want to see in your try catch blocks, that way instead of going to the console or any place the user would ever see it, but you probably want to see it as the developer, you just adjust this slightly to do all this stuff, set up a file handler. And I put 2 words on the board earlier. I put a console handler and file handler. We only use this one But this one just showed up, right? So I only use the file handler. We can explicitly do that, but the console handler shows up on its own. Or at least tags along with the file handler. If we don't say anything, it goes to the console, and the file handler sends it somewhere else as well. So it's not an instead option. Let's see, so anything else in my notes about logging? Yeah, there's nothing real fancy about it, but it's a useful tool. So you might want to kind of work that in somewhere, just to get some practice with it, because when you make software for people, especially if they're computer experts themselves, right? You're making software for a network administrator, they're gonna want some logs. So it's good to know that, and it's also very useful for you. The more automated your software gets, the more likely it is that you won't know about a bug when it happens and have to go back and try to figure out what happened later. That's why, but one thing you'll notice on every log, we never said anything about a date, but every single thing that happens here has a date on it, has the timestamp. So I guess that's an automated process that's one step shorter than writing the text file ourselves. And there are a few other things, the levels, and you can color code those levels, but let's see if I color coded when we did it here. Let me open with, I think I was opening it with Notepad, so let me try opening it. Before we move on to the next thing, I'm gonna try opening it with a good text editor. Color coded it, but I think we actually have to put that into the format object. Open with Sublime shows colors. But it doesn't look like we got any colors here. So we actually have to put that in there. But if you want to add the color coding to the simple formatter, it's just straightforward building up a line. And if you search for color coding in a bash prompt, you will find much, much more useful reference material than you will for color coding in a Java log. The color coding in a Java log is probably going to be very obscure and things like a very obscure thing. That's multithreading. That's the next one on the list. That's one of the ones the homework's about. My expectation is about 25 minutes on this, which will take us right up to about the time we would normally take a break or a good time to wrap up class. So we might be a couple minutes past 7:15, but that's going to be the end of class instead of a break this time. But multi-threading is something we definitely want to work with, because not every program needs to run from beginning to end, right? In flowcharts, if a flowchart looks like that, it kind of has to have a bunch of whatever happens in there. We only have the one option. But something that what a flowchart would normally look like, if we're following good form, is we're going to have a bunch of call boxes. Did that show up on the video? I drew the actual UML picture. Not very clear. I'm going to do that like I think everybody had SDEV 120 here, right? Just the Raptor programming thing. That box isn't very clear. So back in the 90s, when screens weren't any good, they changed the official diagram to something that stands out a little bit more for a call. So we would have something like this. So instead of running straight through it, our methods, our main path, I guess, since I'm drawing a flow chart. Not sure what the term would be. Ultimately a main method, but drawing it as a flow chart, I guess the word's path. Our main path is just calling a bunch of external methods. So maybe the first one
I'll just kind of draw it like this and abbreviate it. Second one, something like this. Maybe another little short one like that. And I'll move toward draw them like threads. Using an analogy, sort of like we have a bunch of different threads we bring together and sort of some sort of crossing pattern, and that locks together to build up an actual textile. That's what our program is composed of. And sometimes they still need to run in perfectly straight order like this, right? Like maybe an average. First thing we have to do is sum together all of our numbers. Then we need to count how many numbers there are. And then we need to divide by that number, divide the sum by that number. That has to happen in a certain order. But other times, they don't necessarily depend on each other. It's just these three things need done. It doesn't matter if we do this one first, or this one first, or this one first. As long as all three of them get done before we get to that end spot in the flow chart, everything's gonna be okay. And when that happens, one of the things about computers really stands out for making that even better, a better way to process. If the order doesn't matter, so if our methods, I'll go ahead and say methods because we pretty much never do anything that's not object oriented anymore. If methods do not depend on each other, we can have the computer jump between them. We say run it, we talk about it simultaneously, but a machine can't do two things at once. So what I'll put some stuff on the picture. If the methods do not depend on each other, we can process it, it as multi-threading. I don't think I came up with a grammatically correct sentence there. I probably should have thought ahead on that sentence or used the one that's in my notes, but the notes are way over there. We can use multi-threading, which means the computer is going to treat, instead of that one big program composed of multiple threads, the computer is going to treat it like a bunch of small programs. So we talk about it as running simultaneously, but time-wise, it's the computer is going to come over here and run through about that much, like maybe run through about that much of the first thread. And then maybe it jumps over here and runs halfway through the second thread. Jumps way back over here, gets a little bit more in that first thread, then hits the second one, gets almost all the way through it, comes back over, finishes the first thread, then finishes the second thread, and then finishes the third thread. So all of them get finished, but the machine's really jumping back and forth. But we're talking about nanosecond time scales. So anytime unless you're really digging into that technicality of the differences, we talk about it as synchronous. These things happen synchronously. So we're going to get the same result. We also have asynchronous multi-threading, where we don't care how it works. Basically, synchronous, think about the end result. So when we get back here, so we jump over here to do all of that, and then when we get to the end, we come back to our flow chart. That would be synchronous multi-threading, and what's synchronous is we get all the threads back at the same time. They return synchronously. We still talk about it as running synchronous, but that's the technicality. So what it is they return synchronously. Alternatively, they did not finish at the same time, right? This one finished first. So we could have got that one back first. And then this one. And then this one finished. So they're not coming back at the same time. So that's asynchronous multi-threading. We get them back at different times. We have the same requirements. Basically, the threads cannot depend on each other because we run part of this one, then jump over here and run part of this one. So if this depended on the result from that first one, we did a big problem. But a lot of times our program can be split up so that everything happens separately like that. And then the computer's ability to rapidly jump back and forth between tasks without losing track of where it's at really shines when we have a lot of tasks that don't depend on each other. And we just need them all to be finished by the same point at somewhere in the future. The computer can jump back and forth in little bits at a time and then ultimately end up back at the spot that end up with the results where it matters, either synchronously or asynchronously. Asynchronously, you might sometimes there's kind of an extra criteria that you have to figure out which order they're in. Here we have 3 methods, so they're defined in kind of an order before we split them up to multi-threading. So when it gets back synchronously, that order is still implied. But when it's asynchronous, we need to put them back in order when they get back. That's sort of the extra step at the end. What I have in my notes, the process of doing more than one thing at a time in our program. It maximizes CPU usage, and it's something the machine does very, very naturally. Jump between tasks without losing track of where it's at. The CPU, right? The CPU cycle fetch an instruction, increment the instruction counter, execute the instruction. That's all the CPU does over and over and over again. So that works perfectly for jumping between instructions. We decided to have split it up, but basically our options are by task or by instruction. Either way, in Java, we extend a class or implement an interface. There's a thread class that we can make a subclass of, or there's a runnable interface that we can implement. Either way works about the same. The differences, we have a lot of the same things. We have a start, run method, and then we get the results back automatically. The differences is the thread class has an interrupt and yield methods as well. So we can assign priority if we need priorities. Like maybe this one is very, very the most critical one. It's like, yeah, we gave you 3 tasks to do, but we really don't care about those 2. This one needs done. So this one can interrupt any other task and to assure that this task gets done first. Or this one doesn't matter at all. The opposite of the interrupt, just yield. If there's another task to run, go ahead and run the other task. We don't care. We don't really care about this as long as we get the numbers eventually, or as long as we get the results eventually. So interrupt and yield, if we need those, we have to use the thread class. Run the interface. The biggest time we would be restricted to only using the interface is if we're inheriting from another class, because we can only extend one class, but we can implement lots of interfaces and get those methods and still count as that data type, or still count as a child of that data type. Basically, we just fill in the run method, and for runnable, we also have to fill in the start method, and then we override a then we create an instance of it in our main and actually call the start method. So let's look at this.
I'll pull up an example to reference. Let's see, I think fall 2019, I had a better example. I looked at them earlier today and put in some notes somewhere, which is way buried in that stack of papers on the desk right now. Which one to look at? I think 2019 had the better example. Examples, there we go. Spread and random, there we go. That's what I wanted. Let's go type this up in code. So I'll close that login example. A very, very useful thing. You will definitely want to get some practice in, and practice with that is easy. Just go ahead and add some logs to one of your programs. There's surely something, at least informational, you could add to pretty much every single program you wrote to get practice with logging. What's this gonna be? Thread and runnable. Sounds like a good name. Get all the clutter out of the way for the class example. Comments can be useful, but they're just kind of cluttering up the screen in our situation today. Which one is shorter? I'll do the class first. Well, both of them are going to be a new class, so we need to create a new Java class, and I'll call this my thread. And have we done this any of this semester? I think we always typed in the superclass, but notice there's a place for superclass and interfaces in the dialog here. Most of our IDEs have that. So I guess in the odds and ends, we should probably look at it. So we have to browse for another class, and if we type thread, well, that's the one we just made, but the very top result is thread from java.language. That's the one we want. Well, you'll notice there's no imports. So java.lang is the abbreviation for java.language. That's the core part of the language. So multi-threading is one of our basic core elements built into with the primitive data. Remember, if you think back over the semester, the only things we've seen that do not require an import are our primitive data, the int, boolean, float, double, string is included there. That's not primitive data, but chars. The primitive data was the only thing we had to import. We were able to do with no imports, but thread can also be done with no imports. So it's part of the core language. And then we set up our class. I'm just going to make a private string, call it name. Sounds like a good name for it. And then set up a constructor, alt insert, and some sort of constructor with, I want one with just a string. Oh, I was looking at the wrong side. Uncheck that. Yeah. The one in our class, not the one from the parent class. I was confused. It confused me for a second. I didn't realize there was a second side to it. It's like, where's all this stuff coming from? It's like, oh yeah, there's a parent class. Sometimes it takes a minute to think about what we're looking at on the screen. And then, like I just said, what we have to do is override the run method or implement the run method. It's actually override because if there wasn't a default version implemented, this would be underlined right now and say that it's not abstract and must implement this thing. So there is a default version. We probably don't want, and like usual, we don't want the default version. So insert and go to override. And we want to override the run method.
And there's the other ones, the interrupt. No yield. Okay, I'm not sure where the interrupt went, but I'll take out the parent one, and now we just define what happens whenever we do this. So like, in our case, I'm gonna just create a bunch of threads. I'm gonna create several of them and say this is, instance 1, instance 2, and we'll just kind of write through that way. Say which one's running. So maybe, go ahead and print out running plus this dot name. We'll say which one's running. And then, I'll put something in a try catch block. So go ahead and type that out. Instead of doing it later like we did earlier. And I'm just gonna run a loop and put it to sleep. Go ahead and give this a pause because that's one of our basic things. We need breakpoints in our method. So some of your other, in a full out version, you would have a class with lots of different methods. And whenever you start running them, you would just put breakpoints between those methods. And then that, which sleeping is an easy way to do that. What can we do? So let's just do a loop. For int I is 0, I less than, oh, I don't know. Math.random times 10. That sounds good. Plus 1. That way we know for certain a number 1 to 10 instead of 0 to 9. I'm going to put parentheses around this and cast that as into an int. And you might be wondering why I didn't call the method to just generate a random integer and that could have ruined the syntax. I haven't done that in Java in a while, and I clearly remembered thought of the Python syntax and knew I was thinking about the Python syntax. And I clearly thought of the C# syntax because it was matf, and I couldn't remember the Java syntax quick enough. So I was like, oh, I'll just do build it up from scratch. I think everybody's seen that before, right? Math.random is a number, a probability, something between 0 and 1, not including 1, but does include 0. So if we need to, we can just multiply that by any number and then floor it. So multiply by 10 gives us something between 0 and 9.9. We cut off the decimal part and add 1, and then we have integers 0 to 1. There is a method there is a built-in method for a random integer. I thought of Python and C# and then just like it's going to be quicker to build it. So if you remember if you remember the syntax for that method, oh, extra prints. If you remember the syntax for the method, feel free to use that. But one of the things is you learn more and more languages, they blend together more. They start to blend together more and more. So you'll memorize all sorts of those things, like the random integer in some range. I'm taking mathf.rand range, that's C#, and it says mathf as mathf for the library, so I know it's not Java. There's one in Java, but it's not hard to build it up from the base piece. And then I don't have to worry about thinking about the Python version or the C# version or the Haskell version or whatever language it is. It's like, no, they all work the same with just the most basic version of random. That can be a good fallback as you learn more and more things. Then I'll just print out this .name as ran plus I plus times We'll say how many times it's run, and then thread.sleep. 123 milliseconds, that sounds good. There's multiple ways to put the thing to sleep, and since we are in a thread doing multi-threading, I'm going to use the sleep method from multi-threading. So that way it's not just like a delay, like the regular java.util.time.sleep, because that pauses everything, and it might not automatically, the CPU might see pause and not realize that it's currently has a bunch of threads, and it'll just pause everything. So if we use thread.sleep, it does still know that there's multi-threading happening. Anything else I need to do here? Oh, when it's done, I can, print out this name as finished running. And in the example I'm looking at here, I put plus system.nanotime. So I must have done the start nanotime somewhere. Oh, I did not do start nanotime. Well, maybe it changed a few times on that data class. But I also added in the example I did plus system.nanotime. So at some point when I was doing that in 2019, there was probably a system.nanotime at the beginning so that we could see how long that took. But there's other ways we can take measurements. I was going to look at other measurements, and I'll just call the stack trace if something goes wrong. But that's all we need to do. It would probably realistically, instead of printing things to the screen, we would probably call other methods in this class. Right? It's going to be a big object with lots of methods that do things. So we would call the different ones and then put that little pause in there so the computer, so thread.sleep is really telling the computer it's okay to go do something else now. This is a good break point. So in our run method, think about it. This is our message to the CPU that this is a good pause point. You can do something else, step away, but don't stop halfway through the line of code. We can only split it up in certain spots. So really what we have to do for multi-threading is give the computer that indication of when it's okay to jump to another thread. And you run down here, oh, we hit a pause point, so then the CPU is going to choose one of the other ones. There are fancy algorithms to handle that. And now we just jump over to our main and create an instance of this. So I'll do like 12 of them. For int I equals 0, I is less than 12, I plus plus. Then for each time, we'll do something called my thread. T is new my thread. And I don't know, thread underscore plus I might be a good name for it. So it's local to the loop, which means it's only going to exist for that pass through the loop. So the next time we come around, that local variable's already been removed from memory, and we can create a new one with the same name. If you're wondering why, I don't think we've done anything, or I haven't asked you to do anything homework-wise that would have required you to create new instances inside of a loop. So when you first see that, it might seem a little confusing. It might be like, wait, won't that contradict? Won't we have 12 of those things called T by the time we get to the end? But local scope is only that one pass of the loop. So by the time we get around for the second pass of the loop, T's already been deleted from RAM, and we can just create another one. And then each time we'll do T.start. So implement the run, override the run method, and then call the start method. Run that. And you can see that those printouts did not come in order. So running thread 2, 4, we started all of them. And that's what we said at the beginning, running the thread. So we started all of those threads. And then we jumped back to thread 3. I guess that could have been a +1 there, because it's obviously ran one time. Ran 3, 7, 10, 6, 4, 5, 1, 8, 2, 9, 11, 0, 4. I saw 4. I remember seeing a 4 before. So 4 ran. How many was that? Did all of them run first? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all of them ran once. I guess if we come down to the end, we'll see, might see some things getting off order. Oh, actually, it looked like that time it went straight in order, 5 times, 6 times. And they finished at different spots because they were all just a random number of times they were going to run. Let me print that a couple times. Well, that's almost systematic. It doesn't always do that. Like all of the zeros and all of the ones. Sometimes they'll get called more often than others. Might have to run it a few times. Or it might just be the fact that we did that in a for loop, so everything's very highly organized as far as the CPU knows it. So even jumping back and forth between tasks, the CPU staying highly organized. Don't necessarily count on it running like all of them the third time and then go to the fourth. I think that's just a by. Yeah, as I think about it, I'm pretty sure that's a byproduct of the fact we use a for loop and structured everything. Everything has an identical structure, name wise, and all of that. So, and we saw how to take measurements, right? We could do a long start equals system.nanotime. Then after we do all of that, yeah. Maybe this is why I had that over there. Long end is system.nanotime. And then print equal marks time is end minus start. So notice where the time showed up. It started thread 1, started thread 2, went back and took that time, then it started thread 3. So it's oh, that one might be more inconsistent. 1, 2, 3. Then we started thread 0. Then a bunch of those ran. Then we started thread 4, then thread 5. But notice it kept running when the program moved on. With multi-threading, the program's not going to wait for that for loop to finish doing all of its stuff before it moves on. That's the big deal with multi-threading. The other one is very similar, so I'm going to type this fast just to get finished and have some examples that'll be loaded on GitHub, and you can copy and paste off the examples. But I meant to be finished a few minutes ago, so let's what's different with runnable? So new class, I'll call it my runnable, and in the interface, implement the runnable interface, which again is we want the one in Java.language. Finish and clear clear all this junk out of the way. Whoops. Let me drag that down into the right package. Refactor, yes. Definitely want it in the same package as the main class. That would be a problem. But this time we have that underline, not all, it's not abstract. So there's not pre built ones, and you can see run is the thing we have to implement, which is just like before. Should I just copy and paste it? No, there's something different we have to do. So I'm going to start the same. I'll just make a private string, call it name. I'll write up what's the same first. Then insert a constructor that takes in that string. Generate that. Yeah, we do that. And then in the run method, get rid of all this and basically do the same thing as last time. System print running plus this dot name or whatever I typed last time. So I'm going to try catch block. And our sprint stack trace. And what we're going to try to do, same thing. I'll just copy it here. Try to do this stuff. So all of that still looks exactly the same, right? That's exactly what we did before. So what I wanted to get to is what's different. Because after we finish that run method, I'll put a label there, we need to define the start method. Because when we go to over to our main or wherever we call this from, probably JSP page in our modern world, not main method, but or a servlet, but wherever we're calling it from, we're going to call a start method, and we have not defined the start method, so we do have to set that up. I'll do this. Starting plus this dot name. Just running it, starting it and running it are different. Everything we've seen so far this semester, running it and starting it are the same. But we do have a slight difference here. And we do have to make sure it's a thread. So the other thing, if you implement the runnable interface, you have to set up a spot for thread data to go. I'll just call it thread. So make sure you create a private data field with thread data type. Because when we call the start method, we want to make sure that it hasn't already started. The computer's gonna, we know the computer's gonna jump back and forth and do lots of different things. And computers are not intelligent, so one of those things is it could keep restarting the same thread if we don't prevent it from doing so. It could keep seeing that instruction, oh, create this thread, oh, create this thread, create this thread, create this thread, and just keep doing that same. The CPUs are not intelligent. So we need to make sure that we're starting a thread that doesn't exist yet. So we do that if that thread data is null. And yeah, then we'll start it. But hopefully that makes sense. Because as soon as that thread has been started, or this thread has been started, that's not going to be null anymore. So the computer won't continually try to restart it as it jumps back and forth between tasks. And if it is, then thread is going to be a new thread. We just go ahead and instantiate it. this and this dot name. Let me pull up the predictive text up. Where's the predictive text not pulling up? Equals new thread. The control space. There we go. Thread is going to be this one. So notice one of the data types we can pass in is runnable. So we start the thread with a runnable, and we implemented the runnable interface. So this class is a runnable. So we want that one. So a runnable, and then a string for the name of the thread. And that's the tag. It automatically goes to a map, which gets turned into a hash key, or sorry, a hash table in the background, which we saw the other day. Once we get in that form of a hash table, we're essentially at the electronic level. I think our class example for a hash table, we had rows 1, 2, and 3 or something. But it would be the actual 8-bit address that feeds into your RAM chip, and data spits out the other side. So once we get our data into a hash table, then we're processing at the speed electricity flows through an integrated circuit. So that's usually our goal. That's what the name is for. So and that also makes it a tag. So we have 2 ways to refer to this. We have the reference name, the normal reference name for our code, but we know there is something it's a string. So in a dictionary in a map with that name we gave this thread with a particular tag we can refer to. And then we'll call the start method. Then we'll call the generic default start method that comes built into threads. If we use the interface, we need to make that check before we call that initial start method. So just a quick confirmation, that's the only thing that's different. Everything else would probably be a copy based off of this. I'll need to take that measurement again. I guess real quick, I could show when if you go to the profiler in NetBeans, there is specifically a threads profiler. This has already gone 15 minutes longer than I meant to, but just click the button for the threads profiler. It's straightforward. There's nothing tricky there. And if you have multi-threads, you can see what's going on. That's how you need to take measurements off of it, because the nano time, it'll go ahead and keep moving past your threads and take the nano time there. So I'll copy that, paste that. Oh, whoops. Maybe not whoops. Yeah, that's what I want. Whoops. That one was a whoops. There we go. So instead of my thread, I want a my runnable. It's going to be a my runnable. And maybe I should call it R instead of T. Probably come up with a much better name than R. Can I put that out again? Oh, no, I guess all the print statements are in the other one. So if I do the runnable, you'll see we got the same results. Oh, this time it looks like it switched around a little. Notice we start the thread, then we start running them. We continue starting them and running them. It still looks very organized. Again, I'm pretty sure that's because we put the exact same thing in a for loop. So it's so structured, the CPU sticks with that structure. Don't count on it always being like, some of them will run once, and then by the time, perhaps maybe thread 2 doesn't run the second time until thread 11 is run 8 times. It's usually something more like that. But I'm pretty sure it's just because of the way we did the code. Configure sessions, set threads. Might as well show this. Hit the attach button.
click the one that says profile project, not attached to external. I have no idea why I clicked that one. And then under configure, hit threads, then profile our current one. It's gonna run. And we close this, we can see like the time each one took and what was going on in each one. And when you do that in a program that's more interesting, the data looks more interesting, but the profile alerts go right in. Okay, that went 20 minutes longer than I meant for it to go. Y'all are probably ready for a break. But pretty much what the rest of the semester is going to be, some odds and ends that I think will be useful. That one's going to be on the homework. You're going to have threads in the homework, and you also have streams. But I also have a big stack of things that will just be useful. They're not on the required learning list, but after many years of programming, I have found they are incredibly useful and probably should have been on that objective list, like logging. Does anybody have any questions about that? I see head shaking no here. Okay, as always, I will be sitting around till 8:50 ready to answer questions if you have any. Text messages and other learn messages are the two things that I'm always on my phone. Otherwise, I'll just be sitting here waiting for questions to come my way. And I'll see you all on Thursday, and we'll just pick up with more odds and ends there. This will be on GitHub in like 5 minutes. So I will see you all Thursday. Everybody have a good night.